Excellent. Welcome everybody. Thank you for participating in our Penn Population Studies Colloquium series. We're excited to be able to continue this long-standing colloquium tradition of engaging population sciences and experts from truly around the world in this discussion. Before I introduce the speaker, I'd like to remind all of you that this colloquium talk and Q&A will be recorded for the purpose of dissemination on the PSC YouTube channel. As you may have noticed, your video and audio are turned off. This is intentional, so don't be alarmed. Please submit any of your questions through the Q&A tool, and the speaker, Sarah Hayford, has asked that if you have questions during the talk, you can submit them during the talk, and I may ask them or call you on asking, or otherwise at the end. So for sure, at the end of the talk, I will call on people to ask their questions using their own voice. And if you wish not to be called on, please submit your question anonymously. So with this being said, I'm truly delighted to introduce Sarah Hayford to give today's PSC colloquium. She is a graduate of our Penn demography program, graduating in 2005, and we're all delighted to have you back, Sarah. And I looked at your CV before today, and it's always kind of impressive to see students who graduate from here and kind of move on and have leave a mark in the discipline and have these kind of impressive trajectories. So Sarah is now professor and director of graduate studies at The Ohio State University. She studies family formation, reproductive health, primarily in the United States and sub-Saharan Africa. So two areas are actually closely related to as well. So her current and recent research topics include the determinants of race-ethnic differences in unintended childbearing, the influences of local context of mothers' plans for their daughters' circumcision in various sub-Saharan African countries, and policy impacts on reproductive health access and outcomes in Ohio. What is also exciting, she's working with kind of multidisciplinary, multi-institutional team to collect survey data on the effects of parental migration on children's socioeconomic development, educational outcomes, and family formation. And that research includes an interesting set of countries, including Mexico, Mozambique, and Nepal. So without further ado, I'm keen on giving the floor to Sarah. Sarah, again, welcome to joining our PSC colloquium, and we look forward to your presentation on age at last birth in the global fertility transition, time trends and regional differences. Please join me in welcoming Sarah.
Thank you so much for that lovely introduction. I will share my screen and start the presentation. I'll go back to the beginning. So this is Hans-Peter shared that lovely introduction about all of the things I'm working on. This is actually a new area. This is hot from the presses, so I'm very much looking forward to your feedback on this. This is joint work with my colleagues John Casterline and Yue Chu. Yue is a graduate student in sociology at Ohio State. And we're thinking about changes in age at last birth as a way of thinking about what women's lives are like after they've finished childbearing. So I've spent a lot of my career looking at birth rates, looking at women's decisions about childbearing, looking at intended and unintended births, with the idea that women's decisions about childbearing have meaning for their lives and the kind of lives they're able to lead. So this is a project that's looking at sort of the length of the lifespan after fertility and what women might do in preparation for thinking about what women might do with that time that they spend after finishing childbearing. So this is a figure that I've displayed in, I would say, about 60% of the talks I've given over the past 10 years, showing something that we all know well, the patterns of fertility decline over the 20th century in what the United Nations World Population Prospects calls less developed regions. So there's been a pretty rapid and massive decline in birth rates in a lot of developing countries. This figure shows sub-Saharan Africa in the blue line at the top, regions in Eastern Asia, South Central Asia, Southeastern Asia, Latin America, and the Caribbean along the bottom, and that orange line is the average for less developed regions. So you can see that in most of the developing world over the course of the 20th century, there was a decline of about 3 births per woman, from about a TFR of about 6 to a TFR of about 3, starting in the 1960s. In sub-Saharan Africa, that decline has been slower. It started for a higher level, it started later, and it's been less of a decline. So a lot of the research I've done has been thinking about why things look different in sub-Saharan Africa and thinking about these regional differences. So as demographers, we know that fertility transition is a huge social change. It has lots of impacts on a society. It has lots of impacts on individuals and families. It affects population size, population growth rate, population age structures. Declines in fertility have impacts for children in terms of the availability of resources, both at the national level and at the family level. And fertility transition has huge impacts on women's lives because women are the one who physically carry children and give birth to children. And women have a lot of the responsibility for raising children. So fertility decline has impact for women's health, for the time they spend in bearing and raising children, and in turn for the time they have to spend on things other than bearing and raising children, for the investments they make outside of the family. And a lot of research on how fertility change has impacted women's lives has focused on changes in the age at first birth. If first births take place at later ages, that leaves more time for women to stay in school. It may leave time for them to work outside the family for pay before they start family formation, before they marry and have children. That in turn has impacts for power dynamics within the family, women's relationships with their husbands, women's ability to make decisions around having children, as well as other things in the family. There's been relatively less attention to age at last birth. You might think that having your last birth at an earlier age would give women more time for non-family activities after they have children. It might also have implications for their family roles, for their responsibilities, for example, as grandmothers or caregivers for other family members. And having an earlier last birth might give women more time to sort of, to put it in economic terms, capture the returns on earlier investments in human capital. So if women stay in school longer before they start childbearing, if they finish childbearing earlier, it gives them more time to do things with that schooling after their intensive time of childbearing and child rearing. And in fact, in the United States, we know that the sort of development of women's labor force participation, there was a phase in which women started returning to the labor force after having children, married women, that sort of opened up the labor force normatively and practically for the labor force participation of married women, and sort of led to a transition into a phase where women continued to work while they were having children and during their intensive phase of child rearing. So this stage of sort of spending time outside of family activities after the last birth can sort of usher in a broader social change around women's labor force participation and women's roles in non-family investments. So as I said, there's been relatively less attention to timing of last birth relative to changes in timing of first birth during the course of fertility decline. There is a sort of clinical biomedical literature on the health impacts of timing of last birth for women's breast cancer risk. That's very much a biomedical literature, not a sort of social literature on the health impacts of timing of last birth. There's a body of research on the changes in age at last birth during historical fertility transitions in the 19th century in Europe. These are fertility transitions that mostly took place without a lot of modern contraceptive technology. And these are fertility transitions that demographers study without a lot of detailed birth history data. So this body of research looks at age at last birth as kind of a proxy for parity-specific control in historical fertility transitions, and looks at changes in age at last birth as a way of sort of capturing the dissemination of fertility control. In contemporary fertility transitions, we might think that age at last birth would be sort of less closely indexed to fertility levels or changes in fertility levels. These are fertility transitions that are taking place in the presence of a lot of modern contraceptive technology. So a lot of ways to control fertility. Spacing may play a larger role in contemporary fertility transitions than it did in historical fertility transitions. So if birth rates decline because birth intervals are getting longer, that would have different implications for age at last birth than if you just sort of follow your same childbearing pattern and stop at an earlier birth. Delayed first births also contribute to contemporary fertility transitions, and those would also sort of tend to push age at last birth later rather than earlier, sort of weaken the link between age at last birth and fertility level. So we might expect that overall there's a weaker connection between fertility level and age at last birth in contemporary fertility transitions, that is fertility transitions that happen in the 20th and early 21st century, relative to historical fertility transitions in 19th century Europe. So in this project, we're sort of starting off with a broad descriptive question about what does age at last birth look like in contemporary fertility transitions? Is there some kind of systematic national variation or regional variation? Are there demographic regimes where age at last birth is systematically later or earlier than in others? And how does the age at last birth change as fertility declines? And is that change different across different fertility regimes? So are there places where age at last birth changes more or less as fertility declines in the 20th and 21st centuries? So this is a talk that only a demographer could love. There's lots of descriptive data, lots of pictures, and lots of sort of thinking about these differences in demographic regimes. To answer these questions, we're using data from a lot of nationally representative fertility surveys. A total of 334 surveys from 73 countries. These are mostly DHS surveys, so mostly demographic and health surveys. There's some world fertility surveys at the early end. There's some mixed surveys at the later end. There's a few of these reproductive health surveys, a few other one-off surveys. We actually started with a slightly larger set of surveys. Not all of them included full fertility histories. So the ones that we've kept are mostly ones that were designed as fertility surveys and do have full fertility histories, or at minimum have age at first birth, age at last birth, and total children ever born. Because we're interested in looking at change over time, we limited analysis to countries with at least 2 surveys, at least 5 years apart. Most of the countries have more than 2 surveys, so the median number is 4, the range is between 2 and 10. And in most countries, we have a fairly large time span of data. So the medium time span is 25 years. The range is between 5 and 44 years. The earliest survey in our sample of surveys is from 1975, and the most recent survey is from 2019. So we're covering a pretty wide time range. And then we also excluded a few small countries, countries with less than 1 million people in population as of 2000. And there are a few fertility surveys from Eastern Europe in the post-Soviet era. We excluded those surveys because those are really pretty different kinds of fertility regimes than most of the places we're looking at. So this is just a list of our surveys. For presentation, we divide them into 5 regions: Central and West Africa and North Asia, or sorry, Central and West Asia and North Africa, South and Southeast Asia, Latin America and the Caribbean, East and Southern Africa, and West and Central Africa. And we can go back to that list if people have questions later. I'm mostly going to show you regional variation and not focusing so much on the individual countries. The analytic sample is women aged 40 to 49 at the time of the survey. So we're looking at women who have mostly completed childbearing and looking back on their reproductive experiences. The upper bound is pretty straightforward. That's the upper bound for inclusion in most of these surveys. The lower bound is a little bit more of a complicated decision. We chose age 44 to balance 2 sort of competing demands on the analytic sample. On the one hand, we need a young enough lower bound so that we have robust sample sizes. We're calculating survey level means. With age 44, we have an average sample size of about 1,500 women in most surveys, a little smaller in some, a little bigger in others. But we also need a lower bound that's old enough to capture most childbearing. Because we're interested in age at last birth, we need an age where most women have already had their last birth. So we looked at retrospective data from women at the oldest ages in the sample. Less than 5% of them report any births after age 44. That is, I think it's about 4.6%. I mean, so that is 4.6% of women who may go on to have another birth after we're capturing them at the time of the survey. We've done a little bit of sensitivity analysis to this. We probably need to do a little bit more sensitivity analysis. The other thing about choosing age 44 as a lower bound is that there is some age heaping in these surveys at age 45. Using age 44 as a lower bound sort of smooths that out a little bit. So our mean measure is age at last birth in years. This is taken directly from birth histories. There are some women who are currently pregnant at the time of survey. For these women, we assume that pregnancies are going to result in a live birth at age 9 months, and we kind of impute that age at last birth. This is for pregnancies of at least 5 months gestation at the time of survey. And then we also look at some elements, other elements of the reproductive career that may go into producing age at last birth. So the number of children ever born, the number of birth intervals, the age at first birth, and the duration of reproductive career. And in all cases, we're looking at these as survey level aggregates. We're calculating the mean, taking into account survey design and weighting within the survey. We also did look at medians. Medians are less sensitive to outliers, so a little maybe possibly less sensitive to exclusion of that last birth among women who are cut off by our lower bound at age 44. The medians and the mean look fairly similar, and the trends in medians look fairly similar to the trends in means, and means have some nice arithmetic properties, which I'll talk about when I talk about the decomposition. So everything I'm going to present today shows you means. So this is largely a descriptive presentation. We're looking at country year as the unit of analysis. So basically one survey is the unit of analysis, and looking at differences across countries and differences over time. We do calculate regional means or medians or slopes for comparison in some of the figures. And for these regional aggregates, we weight all countries equally. So we're not weighting by population size or anything like that. We do some demographic decomposition, which I'll tell you in detail about in a few slides. Looking at age at last birth as a product of changes in levels of fertility, age at first birth, and birth spacing. And all these analyses are taking a cohort approach. So they're looking at experiences of childbearing in individuals' women's lives, measuring fertility by children ever born and not by TFR, and thinking about these as completed fertility among a specific age group or birth cohort of women. So this figure is I would say the core descriptive finding of this analysis. Almost everything I'm going to say in today's talk you can get from this figure. So I'm going to spend some time walking you through this figure, and I will take a look at the chat bar now if I can figure out how to do that. So that if you have questions or observations about this, I'll tell you what we think is interesting about this figure, but I'm also very much interested in hearing what you think is interesting about this figure. So just to walk you through what this figure is showing, these are 5 regional figures with the 5 regions that I showed you a couple of slides ago. Each of these regional figures has the same data on it. So all of these points are the same on each of the 5 figures. It's just that some of the points are bolded for each region, and that's that region's points. Each of these points is a single survey. So this is one country and 1 year. And the figure shows children ever born, average children ever born among women aged 40 to 44 on the x-axis, and mean age at last birth among this group of women on the y-axis. And if you look at the x-axis, you'll see that children ever born goes from a high on the left to low on the right. That's reversed so that it goes in the order of historical time. So as time goes on, fertility declines from left to right. So you can see a couple of things about this figure. I'll talk about what we think is interesting here. So one thing you'll note, there is a clear correlation between mean children ever born and mean age at last birth, as you can see from this figure, that as children ever born decreases, the mean age at last birth also decreases. And these points are pretty heavily clustered around the regression line. That's a regression line including all points, so that's sort of worldwide average regression line for the relationship between mean age at last birth and mean children ever born. There are a few, in some versions of this figure, we marked the outliers 2 standard deviations away from the regression line. There are not many. There are a few at the upper end and a few at the lower end, but basically these points are pretty tightly clustered around the regression line. But there is a spread in mean age at last birth. If you look in the middle of the figure at levels of children ever born between 5 and 6 children per woman, you'll see there's a pretty wide span. From a low in South and Southeast Asia, Latin America, and the Caribbean, around age 31 or 32. So that's India, Indonesia. I think Nicaragua has relatively low mean age at last birth, and that 5 to 6 children per woman level. To a high of around 37 or 38. And that's some countries in Middle and West Africa and East and Southern Africa that have relatively higher mean ages at last birth for that fertility level of around 5 or 6 children per woman ever born. So that's a span of about 6 or 7 years in mean age at last birth from the earliest countries to the latest countries. So that's a pretty significant time span in a woman's life, and sort of suggests that there are some differences in fertility regimes where some fertility is sort of happening at systematically earlier ages in some parts of the world than in other parts of the world. And that does tend to be, if you look at where the points are clustered in each of these different regional figures, they tend to be clustered below the regression line in South and Southeast Asia, and maybe to a lesser extent in Latin America and the Caribbean. So these are countries that tend to have relatively younger reproductive ages. And the points tend to be clustered above the regression line in Middle and West Africa and in East and Southern Africa. So these are parts of the world where fertility tends to happen at slightly later ages. And that's consistent with what we know about birth spacing in sub-Saharan Africa, that birth spacing tends to be slightly longer, more fertility decline happens through birth spacing. And so that pushes age at last birth to later ages. The other thing that I think is interesting about these figures is that on average, I would say mean age at last birth is a little lower than I expected it to be when we started this project. So we do have quite low ages where women stop childbearing, especially at low levels of fertility, and especially again in South and Southeast Asia, some countries in Central and West Asia, North Africa. So mean ages at last birth below age 30 in a fair number of countries. If you look at those points at the very bottom right-hand corner with the very lowest mean ages at last birth, you can see those are shaded in Central and West Asia and North Africa. Most of those are Armenia, which we're also thinking maybe we should be excluding from this analysis. That's kind of a different fertility regime than some of the other countries we're looking at. But quite low mean ages at last birth in some countries in Latin America and the Caribbean as well. Even at the high end, so the highest mean ages at last birth that we observe in this sample are in East and Southern Africa. That's Kenya and Rwanda at the far upper left-hand corner of the figure. So that's around ages 39 or 40 at high levels of fertility. But that's quite far below the biological maximum. That's obviously a mean, so lots of women have ages at last birth higher than that. But that does indicate that there's some sort of social control around ages at last birth as well as ages at first birth that push mean age at last birth well below the biological maximum. Another sort of general comment about these figures, you can see the slope down there in the bottom right hand of the slide. That's negative 1.52. That's the overall slope for all countries in the world. So for every one birth decline in children ever born per woman, there's about a 1.5 year decline on average in mean age at last birth. That's a little less of a decline that you might think intuitively. If you think about what the average birth interval is in most of these countries, it's 2 or 3 or 4 years. So you might think if women have one fewer birth, they have it 2 or 3 or 4 years earlier. The aggregate slope is less than that. So there's some other things that are pushing mean age at last birth higher as fertility declines. That's changes in age at first birth and changes in birth spacing. I'll talk about those in more detail later. And then the final observation I wanted to make about this figure is not specific to mean age at last birth, but just to point out that in Middle and West Africa, you can see that all of those points are on the left-hand side of the figure. Birth rates are still quite high in that part of the world. So we don't really know what the right-hand side of the figure is going to look like in that part of the world. We don't know how mean age at last birth is going to evolve as fertility continues to decline, if fertility continues to decline in Middle and West Africa. So I'm going to talk a little bit about regional comparisons, and that's just something to keep in mind, that we're not actually able to make regional comparisons across the full span of fertility for all of these regions. Now, I can't see the chat. Is there a way that I can see the chat, or Hans-Peter, can you see if there's a chat if people have questions about this figure?
There are no questions so far. So
okay.
I will alert you if there's now one question. Daniel, do you want to unmute and ask your question directly? So Daniel, do you want to unmute and ask directly? Otherwise, I can ask it.
Yes, can you hear me?
Yeah. Mm-hmm.
Yes.
Yeah, I'm just looking at the graphics. This makes kind of intuitive sense to me. I'm wondering, I think you said something earlier about the TFR. Would it be interesting to do a scatter, or maybe I'm getting ahead and you're going to present that? but I work mostly with TFRs and not CEBs. So I'm wondering if you produce those scatters.
We thought a little about that. It's a little bit hard because TFR is inherently a period measure, and I think this age at last birth is really inherently a cohort measure. So kind of thinking about what's the cohort that we would assign to a TFR.
Right.
TFR is capturing a period when actually the mean age at last birth at that time point, most of that childbearing actually happened a long time ago. Right. So it's sort of hard to think about how to align TFR and age at last birth. Right. And so we haven't worked that out yet. We are working all in these cohort measures at this point.
Got it. Okay, thanks.
I have one question. So can you remind me again what the red dots are as compared to the gray one?
The red dots are just the dots for that region. So like in the Central and West Asia, North Africa graph, countries in that region have red dots, countries in every other region have grayed out dots.
Mm-hmm. Perfect. So there are no more open questions. So go ahead, and for sure we're going to come back to this later on.
Okay, great. So this figure is maybe, in response to Hans-Peter's question, this is maybe just a little bit clearer as to which dots belong to which regions. This is the same scatter plot, the same axes, just only showing each region's countries on its plot. And you can see a little bit more clearly on this version of the figure, the kind of different distribution of the points and the different regional slopes. So you do see in some regions in Central and West Asia, North Africa, in South and Southeast Asia, and Latin America, and the Caribbean, relatively steeper slopes, so relatively more decline in age at last birth as fertility declines, and relatively less steep slopes in East and Southern Africa, and especially in Middle and West Africa. So less decline in age at last birth as fertility declines in Sub-Saharan Africa than in other parts of the world. And I'll just say at this point, we're using fertility as essentially our measure of change in all of what I'm going to show you today. We have also done this using historical time as a measure of change, so using years as a measure of change. We had a lot of discussion among co-authors about whether we should be using fertility or historical time, and John Castellan convinced us that fertility is the right scale. But these figures we have them using historical time, and they actually look surprisingly similar using historical time as the x-axis instead of fertility. Roughly on average, as fertility declined in the 20th century in most parts of the world, it declined at a rate of about 1 birth per decade. So if you do this on a decadal scale, the slopes look relatively similar in magnitude. They're a little bit steeper in South and Southeast Asia, where fertility declined pretty fast. They're a little bit less steep in Middle and West Africa and East and Southern Africa, where fertility declined more slowly. But kind of the regional comparisons look fairly similar on historical time to what they look like using fertility change as the x-axis. So these figures all are using 1 dot per country and looking at the regression line through all of those dots. So you might think that within country changes, within country trends over time look different than this sort of aggregate change. So we've also produced figures where we identify individual country trend lines. So this figure is the same principle as the previous figure, where we have 5 regional subfigures, and within each region, that region's countries are bolded and other countries are grayed out in the background, but all data appears on all of these figures. And as you might expect, there's a lot more noise in the individual country trend lines than there is in the overall regional trend lines. Especially in Middle and West Africa, there's a lot of fluctuation in fertility back and forth between surveys. That's partly actual fluctuation, that's partly sampling error across surveys. You can see some funny things in Central and West Africa. That V shape on the far upper left-hand corner is Yemen, where fertility went up and down over time. Again, you can see Armenia, the country in the far right-hand, lower right-hand corner in Central and West Asia, North Africa. But mostly the individual country trend lines look relatively similar to the regression lines, that as fertility declines, age at last birth declines as well. It's a little bit hard to see the different slopes from this figure. So this is just a box and whisker plots of the individual country slope based on those individual country trend lines. And these do come, unlike that previous figure, these are based on fitted lines with linear regression. So they smooth out a little of the up and down from those individual trend lines in each country. So these 5 boxes show the 5 regions. The middle line is the regional median slope from those individual country trend lines. And then we have interquartile range and the minimum and maximum slope in each region. So you can see, consistent with the previous figures, the slope is smallest in magnitude, closest to 0. The median regional slope is closest to 0 in Middle and West Africa and East and South Africa. Also relatively smaller in magnitude in Central and West Asia and North Africa. The median regional slope is larger in magnitude or farther away from 0 in South and Southeast Asia and Latin America and the Caribbean. But you can also see from this figure that there's a fair amount of variation within regions, and in fact, more variation within regions than differences across regions. So there's a lot of variation in trends to capture that we're sort of just beginning to capture at this stage in our analysis. So this is all sort of describing mean age at last birth. In the next set of what I'm going to show you, we're talking about understanding how that overall change in mean age at last birth is produced by changes in fertility rates, which we're measuring by children ever born, and by other changes in childbearing, including age at first birth and the length of birth intervals. So the age at last birth is a pretty straightforward function of age at first birth and length of reproductive career. The length of the reproductive career, again, is a pretty straightforward function of the number of children you have and the average birth interval. Here, there's a little bit of nuance that I'm going to be a little bit sloppy about talking about. The length of the reproductive career is actually a function of the number of birth intervals and not the number of children ever born. So for example, if you have twins, that only counts as 1 birth interval. So this formula talks about parity, which we're measuring as the number of pregnancies that end in live birth. I'm going to talk about that as the impact of fertility level or the impact of children ever born, which is pretty closely correlated with the number of live birth intervals, but not exactly correlated. So the length of the reproductive career is determined by number of birth intervals and the length of the birth interval. So we can write out a nice formula for age at last birth. And if we want to think about changes in age at last birth and decomposing changes in age at last birth between 2 time points, we can just subtract this calculation of age at last birth at time 0, age at last birth at time 1. We can do some rearranging of terms, some simple algebra, and produce this decomposition formula that has reduces different changes in age at last birth to 3 terms. The first term there is the difference in age at first birth between 2 time points. The second term there is the product of changes in the number of pregnancies between time 0 and time 1, multiplied by the mean length of birth interval at time 0. So we're thinking about that as the change in age at last birth that's attributable to change in fertility levels, change in the number of children ever born. And then the third term there is the difference in the length of the birth interval at time 0 and time 1, multiplied by the number of births at time 1, or the number of birth intervals at time 1. So a couple of things about this decomposition formula. One is about this sort of the signs or the order of whether we're subtracting time 0 from time 1 or vice versa. We're talking about change in declines and contributions to decline, so it's always a little bit complicated about whether things should have a negative sign or a positive sign. I've tried to present things here in a way that's reasonably intuitive, and I'll talk you through our presentations, but please do ask questions if you have them about the signs on things here. The other thing about this decomposition formula is that you'll notice a little bit of asymmetry. In the second term here, we're evaluating changes in the number of births based on the length of the birth interval at time 0. In the third term there, we're evaluating changes in the length of birth interval based on the number of births at time 1. So we're evaluating this at different time points. That's sort of algebraically to make things work out nicely so we don't have interaction terms in our decomposition. I think it also makes sense if you think of a decomposition as getting at a kind of counterfactual of what would have happened if some changes had happened and some changes hadn't. We're evaluating changes in the number of pregnancies based on the birth interval at time 0. So what would have happened if only the number of pregnancies had changed and not the birth interval had changed? So I think that makes some intuitive sense. And I'll talk through that as I present the results as well. Before I show you results from this decomposition, I just wanted to give you some sort of intuition as to the scale of changes we're talking about here. So this table shows changes in different elements of the reproductive career in 10 countries. That's 2 countries in each of our 5 regions. These are not representative countries at all. We picked countries that had a relatively long time series in each region. So we're not claiming that these are typical of each region or anything like that. So we have the dates of the earliest and the latest surveys for each of these countries, the decline in age at last birth, and again, that's decline. So positive numbers there mean the age at last birth goes down. The negative numbers for Senegal at the bottom indicate that age at last birth actually increased in Senegal over this time period between these 2 surveys. We have a column showing decline in children ever born, and again, that's decline. So positive numbers there indicate that fertility went down. It did go down in all of these countries. We have change in age at first birth in the second to last column. And so their positive numbers indicate that age in first birth increased, which it did in all of these countries. And then the final column is change in birth interval. And again, positive numbers there indicate that birth intervals got longer on average. So for each of the 10 countries, we have a slightly different time frame that we're listing here. So it's a little bit complicated to compare these numbers across these different time frames. But you do see that there is a pretty wide range in how much age at last birth changed and how much fertility changed over these countries over these time periods. So age at last birth increased a lot, age at last birth declined a lot and fertility declined a lot in Bangladesh, for example, declined a lot in Mexico, much less decline in West Africa, and less decline in fertility in East and Southern Africa as well. Change in age at first birth increased in all these countries by less than 1 year in some of them, by almost 3 years in some of them, and birth intervals lengthened in all of these countries, again, with a fairly wide range on how much lengthening in birth interval there was. So this is the first set of decomposition results. And again, these are sample decomposition results for those 10 sample countries, just to give you a sense of the scale of what we're talking about before I show you the distribution of decomposition results across all of our countries. In this figure, this decomposition is scaled to a 1 birth decline in children ever born. So we calculate that decomposition formula and then we divide by the change in fertility over this time period for each of these countries, so that these are more easily comparable across countries that have different time periods and different size of fertility declines. And these are signed to match the sign in age at last birth. So these green bars are the change in age at last birth that's attributable to children ever born. Those are all above 0, so those are positive, indicating that they go in the same direction as changes in mean age at last birth. So as fertility declined, mean age at last birth also declined. And as you can see, for all of these countries, the change attributable to fertility decline is between 2 and 3 years decrease in age at last birth. And that's kind of what we would have expected intuitively based on birth intervals in these countries, that when fertility declines by an average of 1 birth per woman, age at last birth should decline by about the length of a birth interval. And again, we're evaluating this at the birth interval at time 0, the start of fertility decline in all of these countries. So that's between 2 and 3 years. And that's what the amount of decline in mean age at last birth that's attributable to change in fertility levels in these countries. Now, the change in mean age at last birth that's attributable to age at first birth and attributable to changes in birth spacing or birth intervals go in the opposite direction of mean age at last birth. So if all other things had been equal, changes in age at first birth and changes in birth spacing would have led to an increase in mean age at last birth, would have pushed age at last birth later. And the change in age at first birth, the amount of change is sort of between 0 and 1 year in mean age at last birth for each one birth decline in fertility. And a slightly larger amount of change is attributable to increased birth spacing in most of these countries. And you can see the countries with the largest amount of change attributable to changes in birth spacing, in this figure at least, in this set of 10 countries, are Indonesia and Senegal. Because that impact of changes in birth interval are evaluated at the later time period, according to our decomposition formula, countries with relatively high fertility levels at the latest time period, like Senegal, have a relatively larger impact of birth spacing because women are still having more children, so the length of the birth interval matters more. And in Indonesia, actually, fertility is relatively low, but birth intervals have really increased a lot over the course of fertility decline. So you see in Indonesia as well, a relatively large proportion of change in the mean age at last birth is attributable to changes at birth spacing. So birth spacing really compensates for reduction in mean children per woman in Indonesia. So these are decomposition results for 10 sample countries. If you look across all of the countries in our survey, we've again summarized these in a box and whisker plot, where we have one plot for each region showing the sort of distribution within that region of the decomposition components. So the blue bars here show the amount of decline in age at last birth. And again, these are signed in terms of decline. So the blue bars are above 0. That means that there was a decline in age at last birth in most of these countries. And again, the line in the blue box represent the median decline in age at last birth in each region. The red boxes in each region, that's the second box from the left, are the amount of change in mean age at last birth that's attributable to decline in fertility, decline in mean children ever born per woman. And those are fairly similar across regions, and there's fairly little variation within regions. So again, that's because that impact of declining births per woman is evaluated based on the birth interval at time 0, which is fairly similar across countries at the starting point. The yellow box, that's the box that's second from the right in all of these figures, is the amount of change in age at last birth that's attributable to increases in age at first birth. This yellow box is below 0 in most of these regions for most of these countries. That's age at first birth is increasing, so it's sort of pushing age at last birth in the opposite direction from other components of change. And there is more variation there, as there's some countries where there's really quite a lot of change in age at first birth, some countries where there's relatively little change at first birth. You can see in South and Southeast Asia, age at first birth is relatively substantial, but also in a lot of countries in Middle and West Africa, substantial change in age at first birth, and a sort of wide range in Middle and West Africa, where there's quite a lot of variation within the region as well as differences across regions. And then finally, the green boxes on the far right-hand side are the amount of change in age at last birth that's attributable to changes in birth spacing. And there again, we have quite a lot of variation within regions, a little bit hard to make cross-regional comparisons. Maybe we can say in Latin America and the Caribbean, that's a fairly a fair amount of similarity within that region, but in the other regions, there's quite a lot of differences, maybe more relevant to talk about within regional differences than across regional comparisons. Okay, so I just want to summarize the findings here. We have a lot of descriptive findings and some key points to take home. First of all, at similar fertility levels, mean age at last birth on average tends to be slightly higher in sub-Saharan Africa, especially in West and Central Africa, and slightly lower in South and Southeast Asia and in Latin America and the Caribbean relative to other world regions. So we do see differences in fertility regimes across countries and across world regions. Age at last birth declines as fertility declines everywhere. Worldwide by about 1.5 years in mean age at first birth for every 1 child decline in mean children ever born per woman. Slightly less than that in sub-Saharan Africa because of increases in birth spacing over time. And declines in fertility would have produced even larger declines in age at last birth if age at first birth hadn't increased during the course of fertility decline, and if birth intervals hadn't lengthened during the course of fertility decline. So we have a couple of next steps from this analysis. One is to incorporate variation as well as central tendencies. So to think about how the standard deviation of mean age at last birth changes with fertility declines, as well as the mean age at last birth. So we see greater variation within countries as fertility declines, as there's sort of more inequality in fertility. We also want to think a little bit about explanations for why some of these patterns might look different across different world regions. One of the things you might note, if you know something about contraceptive method mix in different world regions, is that in South and Southeast Asia and in Latin America and the Caribbean, there are a lot of countries in those regions that have depended very heavily on sterilization during the fertility decline. And those are the countries that tend to have younger mean ages at last birth. And also, interestingly, younger ages at first birth in a lot of cases. So fertility just sort of shifted to very early in women's life course and ending early in women's life courses in those parts of the world. So the role of other kind of contraceptive method mix may sort of be relevant in understanding some of these different fertility regimes. We've also thought about whether these different fertility regimes, sort of an earlier versus later fertility regime, or a fertility regime where childbearing is compacted into a very short time period versus spread out over a longer time period, whether that might sort of have different implications for women's education, for example, or women's labor force participation. It's a little harder to think about causal direction in those social characteristics. But it would be interesting to think about those correlations, and that's sort of a next step that we have in mind to look at some of those country level variation and linking that to other country level differences. But this is really the first step in a project thinking about the changes in fertility timing and impacts of those changes on women's life course and time use. Of course, the age at last birth isn't the end of women's reproductive responsibilities. Women may still have a lot of caregiving responsibilities. And in some parts of the world, declines in the number of children people have been linked to increased investment in the children that people do have. And that may be disproportionately concentrated among women. Women may have disproportionate responsibility for caregiving for children. So you might think that fewer children might not sort of decrease the amount of time that women have to devote to children. It's challenging to measure that, but we could think about women's caregiving responsibilities and trying to keep track of women's caregiving responsibilities, as well as just the timing of births. The other thing that we'd like to do long-term is to connect this with measures of changing life expectancy across regions, and especially changes in healthy life expectancy. So we might expect to see sort of even greater regional inequality when we looked at the time women have left after they finish childbearing and not just the age at which they finish childbearing. So I will stop there and open things up to chat. And I am also open to questions or comments over email if they come up after the talk today.
Sarah, thank you very much. This was kind of truly exciting and close to my heart as well. So I'll invite everybody to submit, questions through the chat. If you do this with your name, I'll call on you and you can ask directly. And if not, I'll ask any anonymously posted questions on behalf. But I'll take the freedom to start off by myself. So I looked at this kind of in a very different context, Sweden, I believe, kind of many years ago, and we documented this kind of U-form pattern of basically, declining in age at last birth driven by fertility reduction, and at some point a increase in age at last birth driven by delays of childbearing. And I wonder whether you expect this to happen in younger cohorts, and in the same spirit, I wonder whether it might make sense to kind of project ages at last birth in the younger cohorts based on some of the earlier markers, life course markers you have to basically. Anyway, for quite a few cohorts, you have rich data and you could easily project that out 10, 20 years and see whether that's likely to continue to downward trend, or whether one might see something like this U-shaped because in some ways that's fundamentally interesting for these, profound transformations of the life course.
Yeah, and are you thinking about this question in low fertility context or in high fertility context?
No, in the low fertility context, we know. I'm exactly interested in kind of as the transition unfolds in these countries. It's not yet relevant in countries that have a TFR of 5, but as these countries, TFRs declines and they get to 2, 3, 2, or lower, that may not be too far off. And anyway, it's conceptually an interesting question to ask when this reversal in the age at last birth occurs. And you don't know it yet, but you could kind of use the younger cohorts to project that or ponder about this, because I suspect some of these cohorts may not be very far away. Again, I think it's just because, think about when fertility occurs in the life course, it's an interesting marker of when one says the timing of fertility in the life course is fundamentally transformed when you kind of see it kind of being delayed again, and kind of the age at last birth being moved, going upwards.
Yeah, I mean, I think it's a complicated kind of projection because when people are only having 1 or 2 children, there's not that many things to project. I mean, you can sort of project the age of first birth, and you can project birth intervals pretty well. So you could sort of do some anticipation of what younger cohorts would look like. When people are having, even 2 or 3 children, and certainly when they're having more than 2 or 3 children, you're sort of projecting a lot of things at once. You're projecting potential changes in the start of childbearing. You're projecting changes in parity progression ratios. You're projecting changes in birth spacing. So I think it would be a much more complicated problem to try to think about what future cohorts would look like based on current cohorts when you're projecting more than 1 or 2 things. So I'd be careful about wanting to take on that kind of problem for a lot of these countries. But I mean, in theory, you could certainly do it and sort of try to take into account some of those moving parts.
Okay, thanks. So now I want to give some other people. So Sizong had a question.
Okay, sorry, I was muted by the host. Sarah, thanks so much for the presentation. It's a super interesting and important project. So our question is related to male fertility, because I noticed that at least until 2017, I believe the National Vital Statistics report still include males' age-specific fertility, so that we can also calculate the mean age of childbearing. I'm not sure about the last, the age at last childbirth, but I just wonder if it is possible for us to do similar analysis for males and see if we observe the trends only for females, or if you think we should observe similar trends for males as well.
I mean, that's an interesting question. And I think it's a question, as a lot of questions about male fertility, where we're really limited by data. Certainly, it's much harder to do these long time trends over historical time for men. The DHS surveys have recently started collecting data for men, but that's really pretty recent. And I think that it's also a little bit more challenging to do parallel analyses for men because of that right tail, where men's fertility isn't as limited by biological capacity as women's fertility is, although it is to some extent. But you would expect a few men having last births at very late ages that might be very hard to capture in survey data, or you could capture it better in vital statistics data. But so I think you'd have to pay much more attention to outliers and to the sort of sensitivity of the sample age range for men as for women. Overall, I think that men's fertility is more similar to women's than we might think. The analyses that I have tried to do using US data for men's fertility, they're actually quite similar. People have children for them, not exclusively, but for the most part, in heterosexual couples, and heterosexual couples for the most part are pretty closely age matched. So things don't look totally different would be my guess, but I think that they might look quite different, and especially in countries where there's polygamous marriage, in countries where there's much bigger age gaps between spouses. I think there would be a lot of complexity just to think about in doing parallel analyses for men.
Okay, thank you.
Thank you. Now I'm going to let Herb ask a question. And if I'm not wrong, Herb is probably connecting from Paris.
Yeah, hi, Sarah. You're onto this with your comments about contraceptive mix sterilization, but here goes anyhow. How do you know when you've had your last birth? And does this matter for the related issues, that is, the issues related to age at last birth in women's lives that you mentioned in your intro? So great to hear and see you. Best, Herb. Oui, je suis à Paris.
Well, good evening in Paris. Yeah, so this is purely, I suppose a more accurate title for this would be last recorded birth in survey or most recent birth in survey. So in theory, this may not be the last birth that women actually have, as we talked a little bit about the sensitivity of our results, the choice of lower bound. And we're certainly not looking at all in whether women want this to be their last birth. We do have, in most of these surveys, we have questions about desired fertility, desired family size, desired future fertility. So we could account for whether women say they don't want any more children or whether they do want any more children, and sort of calculate some kind of desired or planned or intended age at last birth. And that might be more relevant if we're thinking about like sort of how women invest their time, and do women go to school thinking that they're going to go back to work after having their last child. That sort of planned or intended or desired end of childbearing might really be the thing we want to capture. And we haven't thought about measuring that at all, but we certainly could, and it would be relatively straightforward, and it might be interesting to do that.
Okay, thank you. Because we're running up on time, I'm going to give possibly the last question. We'll see, to Michelle Gouillot.
Hi, Sarah. Nice talk. As you're thinking at the end about possible factors for explaining these changes in both the number of children overborn and birth intervals, was wondering if you also thinking of potentially include breastfeeding as a factor, because obviously in sub-Saharan Africa, it's going to be probably playing a large role in explaining these long birth intervals, but also integrating, of course, child mortality, which both has an impact on birth intervals and the number of children overborn. And then a more technical comment about your concern about having an asymmetric decomposition. You could just use a three-way Dasgupta decomposition, which wouldn't change the results very much, but at least they would be completely symmetric and you wouldn't have to worry about that aspect of your decomposition.
Yeah, thank you. Actually, those are both really great suggestions. And I mean, one of the things we wanted, there's obviously lots of ways you can decompose things, and we want to do a little looking into how sensitive the results are to that decomposition. It's sort of the balance between sensitivity and the sort of intuitiveness of an easier or more straightforward decomposition. But yeah, breastfeeding and child mortality are also sort of core components of fertility decline that are clearly linked to all of these things, and I think would be useful places to start in thinking about explanations for why things look different across different countries.
So thank you. Since you had an efficient answer, we can give the last question actually to Daniel Goodkin to come back and ask one more question.
Can you hear me?
Yep.
Okay. Yeah, I was going to follow up Herb's question by asking about Paris. Hi, everybody. I guess my question is, in very low fertility countries, I'm wondering whether you might consider bringing them into this analysis. I keep thinking of the period ASFR. Over time, the peak tends to go into the 30s rather than the 20s. So I'm wondering if adding in higher income countries might help to, I don't know, enhance the analysis in some way.
Yeah, and I was a little unnecessarily dismissive in talking about existing research on age at last birth, which is actually much more of that in high fertility countries because of in low fertility countries and high income countries, because of concerns about very low fertility, because of concerns about birth postponement leading to foregone births, there's much more worry about people sort of reaching biological maximum ages of childbearing without having had all the children they want. So much more policy attention and much more research attention to age at last birth in low fertility countries. So there is a relatively robust literature on that, which we could refer to more in sort of situating this research and contextualizing our findings.
Okay, thanks.
So to wrap up, thank you, Sarah, for giving a exciting, stimulating presentation. You could tell from the chat there's a lot of interest in this, and you're onto something that's both difficult and challenging. So I'm glad you're doing it. So you're going to learn something from this. To everybody, thanks a lot for participating in today's colloquium. If you have additional questions, please reach out to Sarah directly. You have her email here. Please come back next week. Thanks again. Bye-bye.
Thanks so much.